Welcome back. This is lesson 7.6, journal using algebraic expressions. I will be able to evaluate, I'm sorry, I'm doing that wrong. I will be able to define a variable. I will be able to define a variable, write an algebraic expression, and use it for real-life situations. So vocabulary for this lesson: variable, that's when we use a letter to represent an unknown value. Algebraic expression is turning a situation into math language using numbers, variables, and operations. And evaluate means to find the value of it, so that's when you plug in a number for a variable and figure out what you get. So here it says define a variable or variables if there's more than one. Write an algebraic expression and then evaluate each expression for the following situations. Arnold drove 125 miles yesterday. He finished his trip today. Write an expression to represent the total number of miles he has driven. Well, to begin with, we have to define a variable, meaning we're just going to pick a letter, but we have to say what it means. So the thing that we don't know in here is he finished the trip today, but we don't know how far he traveled today. So I'm going to put M for miles traveled today. That is what we don't know. So the expression, if we turn this into math language, he did 125 yesterday. Then he traveled more miles today, so that means I'm going to be adding that on. So 125 plus M would be the expression. This could mean he traveled 1 mile today. It could mean he traveled 2,000 miles today. We don't know. Now it says evaluate if he drove 215 miles. So we're just going to replace M with 215. So 125 plus 215. Now I can figure out exactly how far he drove. So if I were to add this up, it's easier for us to do if we stack it. 5 plus 5 is 10, regroup 1. 1 plus 2 is 3, plus 1 more is 4. And 1 plus 2 is 3. So he drove 340 miles. Now evaluate if he drove 290 miles. So now we're changing the value of M. So if he drove 290 miles, we would plug that in. So 125 plus 290. I'm going to stack it to make it easier to add. 0 plus 5 is 5. 2 plus 9 is 11. Regroup 1. 1 plus 1 plus 2 is 4. So that would be 415 miles. So, as you can see, the variable has to represent something we don't know. The expression is for any amount of miles. And now these are evaluated for amounts we do not know. Okay, let's try this next one. Elizabeth has triple the amount of money than her brother has saved. Write an expression to represent the amount of money she has saved. So what do we not know here? We don't know either of them, but I don't know to begin with how much her brother has saved. So I'm going to put B. B for money brother has saved. Now how does that relate to the amount that Elizabeth has? Elizabeth has triple. Triple means 3 times what? 3 times what her brother has saved. So to write 3 times what her brother had saved, it would be 3 times B. Or we could just write 3B. Alright, evaluate if her brother has $38. So we'd write 3 times 38. So 38 times 3. 3 times 8 is 24. Regroup 2. 3 times 3 is 9, plus 2 is 11. So we get $114 if he has $38 saved. Evaluate if a brother has $2. Same idea, replacing B with 2. So that would mean he would have $6. Next problem says, Ben needs to order some new socks. Toes brand is on sale for $4 per pair, and then there's a $3 shipping charge for each order. Write an expression for the total cost of any order. Well, what can change, or what is it we don't know here? We don't know how many pairs of socks he's going to order, so I'm going to write P for pairs of socks. So defining the variable, P represents pairs of socks. Alright, now we have defined what it's going to be. How would we figure out the price? So it costs $4 per pair. I don't know how many pairs he's going to buy. So I'm going to do 4 times the number of pairs. But is that all we have in our cost? No, we've also got to add on a $3 shipping charge. Now this isn't $3 for each pair. It's just a $3 charge for each order. So no matter how many socks he orders, it's just going to charge $3 to get it to your house. So there's an expression to go with this. So 4 times P plus 3. So evaluate if he orders 4 pairs. So 4 times 4 plus 3. 4 times 4 is 16 plus 3. That means it's going to cost him $19 to order 4 pairs of socks. Evaluate if he orders 2 pairs. Same idea. 4 times, except for this time it's 2 because he's only ordering 2 pairs of socks, plus 3. 4 times 2 is 8, plus $3 to ship it to their house. That would be $11. So you see how the value of each expression changes depending on the value of the variable. But this expression summarizes it for any amount of socks he wants to order. Okay, let's try this next one. To find the volume of a cube, you must multiply the length times the width times the height. If all of the sides are the same length, write an expression to represent the volume of the cube. So all the sides are the same length. What's going to be the thing we don't know? We don't know how long each side is. So I'm going to write S is the side length. So an expression for this would be length times width times height. But they're all the same because it's a cube. Another way we could write this would be S to the 3rd power. So based on that, it says evaluate if the side is 13 centimeters. So that would be 13 to the 3rd power. That means I'm going to do 13 times 13. 9, 3, 0 placeholder, 1 times 3 is 3, 1 times 1 is 1. Add that up, we get 169. But that's only 13 times 13. I now have to times 169 by 13. 3 times 3 is 9. 3 times 6 is 18. Regroup 1. 3 times 1 is 3, plus 1 more is 4. 0 placeholder. 3, 6. Oh, what did I do wrong here? That should be a 9. Oops. Scratch that, try again. 3 times 9 is 27. Regroup 2. 3 times 6 is 18. Plus 2 is 20. Regroup 2. 3 times 1 is 3, plus 2 more is 5. 0 placeholder. 1 times 9 is 9. 1 times 6 is 6. And 1 times 1 is 1. Add it up. 7 times, or just add it up. 7 plus 0 is 7. 0 plus 9 is 9. 5 plus 6 is 11. Regroup 1, and that would give us 2. So what is our final answer? 2,197 centimeters cubed. Okay, Kanab is 4,830 feet lower in elevation than Brian Head. Write an expression to represent the elevation of Kanab compared to Brian Head. So we don't know how high Brian Head is. So that's going to be my variable. I'm going to put B for Brian Head. Brian Head's elevation. So my expression, if I want to figure out how, let's see, to represent the elevation of Kanab compared to Brian Head, so I would take Brian Head minus Kanab, which we know is 4,830 feet lower. So if we want to find how much Kanab is, we know Brian Head is 9,800 feet now. So here's my expression now that I know what Brian Head is. 9,800 minus 4,830. 0 minus 0 is 0. 0 minus 3 we can't do, so we're going to have to borrow. 10 minus 3 is 7. 7 minus 8 I can't do. 17 minus 8 gives me 9, and 8 minus 4 gives me 4. So Kanab's elevation must be 4,970 feet above sea level. Okay, last problem. It says Melanie uses 1 1/2 times as many blue beads as she does white beads making her necklace. Write an expression to represent the number of blue beads she used. So, what is the thing we don't know? We don't know white beads or blue beads, but we know how many compared to white. So I'm going to use W for my variable. W represents white beads. So she uses 1 1/2 times as many. So I'm just going to do 1 1/2 times W. So it says evaluate if she used 240. So 1 1/2 times 240. Okay, I'm going to make this improper to make it easier to work with. So 3 over 2 times 240 over 1. Cross cancel here. 2 goes into here 120 times. Times across the top, we get 360 over 1. So that means she used 360 blue beads. Alright, rate yourself on this concept. Can you define a variable? Can you write an expression? And then can you use that expression to evaluate a situation? 0, 1, 2, 3, or 4. Take a picture and turn it in on Google Classroom.